Everyone, I hope everyone is fine amidst this COVID crisis. Well, today we will learn about logarithmic amplifier. It is another application of op-amp. I hope everybody is revising all the other applications. And if you have any queries, please drop in your queries in the chat box. Okay. So the circuit for logarithmic amplifier is like this. We will ground this terminal 3, and in the inverting terminal we'll apply a voltage. Okay, and this is resistance R. Let I be the current flowing through this resistance, and as usual in all my diagrams I consider this point, so let this point be A. And over here I am drawing a diode. Okay, so a diode is present over there. This is the positive part of the diode, this is the negative part. Okay, I'll write it down for you also. And let IF be the current that is flowing through the diode. I hope you all know that a diode conducts in the forward bias only. So this figure shows the circuit diagram of a logarithmic amplifier using op-amp. Is my figure visible? Okay. Since there exists a virtual ground at the input of the op-amp, the potential at this point A is 0. Okay. So as the input impedance is infinite, same current will pass through resistance R and also through the diode D. So we can write I is equal to Vs minus 0, because over here by virtual ground concept the potential is 0. So Vs minus 0 by R, and this is the same current that will be flowing through the diode, so I'm writing it as IF and make this equation as 1. Now again we know that forward biased diode current relation, okay, we know the forward biased diode current relation is given by this very relation, which is very famous relation. So e to the power q Vf by nkt minus 1. So consider this as I naught is equal e to the power q Vf by nkt. Pardon my handwriting, I'm trying to deliver you the concept as much as possible. So this forward current IF is equal to I naught e to the power QVF, F is in the suffix, by nkt, where I naught is the reverse saturation current. Okay, now over here Vf, I can write over here that Vf is equal to 0 minus V naught is equal to minus V naught, we can see from the diagram. Okay, so what will happen to IF then, as Vf is equal to 0 minus V naught is fetching you minus V naught, that is Vf is equal to minus V naught, then what will happen to the relation for I? So let me move on to the next page. So it will become I is equal to IF is equal to I naught e to the power minus Q V naught, because Vf is equal to minus V naught, so I'm replacing that over here in place of Vf and write the rest as it is by NKT. So V naught is equal to minus NKT by Q. We'll write ln I by I naught, or V naught, just simple calculation you have to do over here. NKT by Q, I can write this as Vs by I naught R. Make this as equation number 3. So you can see over here that the output voltage is proportional to the logarithm of the input voltage. Okay, Vs was my input voltage, so output voltage is proportional to the logarithm of the input voltage, and this is an excellent device which can respond to a wide range of input voltages. Now simply by interchanging the positions of R and the diode, one can construct an anti-logarithmic amplifier. So I hope this section is quite clear to you, and if you have any queries, you can drop in your questions. Okay,